Hello everyone, myself Sharada Alok. I welcome you all to your very own channel. Let's crack NEET UG in English. And yes, guys, today is the discussion of previous year's questions on the topic coordination compound. And this is one of the most important topic of inorganic chemistry, guys. So this discussion of coordination compound I have made in two sessions. So today is the first session because so many questions have been asked so far under the topic coordination compound. Come on, guys, let me tell you how you can get connected to us. First of all, go to Play Store, download the Unacademy Learning app, and then click on to NEET UG and straight away go ahead for the Plus subscription, guys. You'll be getting two type of subscription. The another one is Iconic subscription. Under Plus subscription, you'll be getting daily live classes where you can chat with your educator, engage in discussion, ask all your doubt, and answer in the poll, all while the class is going on. You'll be getting live tests and quizzes which will help you to evaluate your preparation with regular mock tests and quizzes, and you'll be getting a detailed analysis of your performances as well. You'll be getting a proper structured course, and all our courses are structured very much in line with the exam syllabus which will help you to prepare your best for it. So all by having one plus subscription, you get access to all our live and recorded courses which you can watch from the comfort of any of your devices. Now, let me tell you about Iconic subscription. This will definitely take your NEET UG preparation to the next level with personal coach. Come on, the top educators across the nation will be your personal coach. You are going to get one-on-one guidance from top exam expert as a personal coach in order to align your preparation strategy. You'll be getting an in-depth test analysis with personalized feedback, which will definitely improve your time management and of course exam approach. Come on, guys, you'll be getting a proper study planner that will definitely ace your preparation. You will also get a bi-weekly review that will highlight your progress. So all by having one Iconic subscription, you'll be getting live classes from top educator, mock test and quizzes, structured batch courses very much in line with exam syllabus. Let me tell you guys whether to go for plus subscription or the Iconic one. Listen, choice should be all yours. You need to select a subscription plan that suits you, but whatever you are going to get under plus subscription, you'll be getting all that under Iconic one along with the Iconic features under Iconic subscription, guys. And those features, those Iconic features are you'll be getting personal coach, study planner, expert guidelines, and of course, in-depth test analysis. Now, guys, let me tell you how much you'll have to pay if you want to go for Iconic subscription. First of all, you can go ahead for 6 months, 12 months, and 24 months subscription. For 6 months, you'll have to pay 38,000. For 12 months, you'll have to pay 65,000. For 24 months, you'll have to pay 1 lakh. But if you apply this referral code of mine, you'll find that you will have to pay only 34,200 for 6 months, 58,500 for 12 months, 90,000 for 2 years. Come on, this is going to cost you only 3,750 rupees per month. And remember, guys, all the student of class 12 or dropper, I just want to tell you, recommend you personally that you need to go for at least this 6-month subscription plan so that you can start your preparation, because this is going to cost you only 5,700 rupees per month. Remember, guys, now let me tell you about plus subscription. Right from 1 month, 3 months, 6 months, 12 months, and 24 months subscription, you can go ahead for. So, guys, for 1 month, you'll have to pay 7,000. For 3 months, you'll have to pay 17,500. For 6 months, you'll have to pay 28,000. And for 12 months, you'll have to pay 58,500. For 2 years, you will have to pay 56,000, which is going to cost you only 2,333 rupees. Come on. If you apply this referral code of mine, SA10, guys, for 1 month, you'll have to pay only 6,300. For 3 months, you'll have to pay only 15,750. For 6 months, you'll have to pay 25,200. And for 12 months, you'll have to pay 34,650. And for 2 years, you will have to pay 50,400, which is going to cost you only 2,100 rupees per month. Remember, if you're a student of class 12 or dropper, guys, either you want to go for plus subscription or the Iconic one, 6-month plan is going to be the best for you. So start your preparation by taking the subscription so that you can ensure your selection. Now, guys, one more thing. If you really want to prepare for NEET 2021, and like you have lost the umeed, or you are thinking that how come like if you have not studied at all so far in a vigorous manner or in a proper manner, and you are worried that whether I'll able to complete it in this another 6 month, or I mean whatever time we are left with, then you must join this batch. This batch is actually meant for you type of student, guys, remember. And this is starting from 3rd of January. It is a crash course for NEET 2021. If you really want to prepare for medical entrance examination with top educators, do join this Umeed batch for NEET 2021. You'll be mentored by Dr. Anand Mani sir, Aman Kumar Singh sir, Deepak Vashish sir, Vikrant Kirar sir. Guys, this is me, the batch for NEET 2021. This is going to start from 3rd of January. Do join this batch. Come on, you'll be mentored by Dr. Anand Mani sir, Deepak Vashish sir, Vikrant Kirar sir, and Aman Kumar Singh sir under this batch. Or guys, if you really want to score a super rank in NEET 2021, then you can join the super rank batch. This is again a crash course. This will make you to get super rank in NEET 2021, and this is right from 28th of December, guys. You'll be mentored by the top educators under the batch, under this batch till NEET 2021. So prepare for medical entrance examination with top educators. Come on, you'll be mentored by Ashish Diwan sir, Pankaj Talwar sir, Ritu Ratewal ma'am, Pradeep Chitora sir, and Rohit Kumar sir. Right from 28th of December to the NEET 2021, you'll be mentored by all of them, and you will able to score a super rank, guys. Come on, guys. You'll be mentored by Ritu Rattewal, ma'am, Pankaj Talwar, sir, Ashish Diwan, sir, Pradeep Jatora, sir, and Rohit Kumar, sir, under the Supers Ranker batch, which will make you get super rank in NEET 2021. Now, guys, if you really want to have a vigorous practice, then this batch is meant for you. Sorry. Then this batch is meant for you guys. Abhyas batch for NEET 2021. This is going to make you practice in a vigorous mode, guys. This is for NEET 2021 revision, and do prepare for medical entrance examination with top educators and have a vigorous practice. And you will be mentored by Anmol Sharma sir, Gaurav Verma sir, Pankaj Talwar sir, Shashi Prakash sir under this batch. So, guys, don't leave this chance, this wonderful chance to be mentored, to get mentored by Anmol Sharma sir, Pankaj Talwar sir, Gaurav Verma sir, and Shashi Prakash Singh sir. Do join this batch and have a vigorous practice for NEET 2021. Come on, guys, let us start for the discussion of the very first question. So we have the very first question before us is the correct order of the stoichiometries of AgCl formed when AgNO3 in excess is treated with the complex this, or this one. Remember, all the complexes are different. Now let us see, guys. Let us see the very first complex, COCl3.6NH3. So, guys, according to Werner's theory, the complex can be represented as CONH3 whole 6 with a charge of 3 plus, then 3Cl minus, isn't it? So this has 3 ionizable chloride ion. Now the next complex will be represented as COCl3 5NH3, guys. This will have, because the coordination number is 6. So, guys, along with the NH3 ligand here, it will also have chloride. Done. Now, this complex will have a charge of 2 positive as per Werner's theory. And 2Cl minus will be outside the complex or will be present in the ionization sphere. And the third complex, which has 4 NH3, as per the Werner's theory, this can be represented as there would be 2 Cl in the coordination sphere with a plus 1 charge and 1 Cl minus will be outside. This is the ionization sphere, guys. Remember here. So as per the ionization sphere, we have to decide the precipitate. Okay. So guys, as 3Cl minus are outside, I mean you will be getting in the aqueous solution 3 moles of Cl minus in this case. So this is going to react with 3 moles of AgNO3 and you'll be getting 3 moles of white precipitate of AgCl here. The second one will require 2 moles of AgNO3 and will give 2 moles of AgCl white precipitate. And the third one will give 1 mole of AgCl white precipitate reacting with 1 mole of AgNO3. Therefore, guys, the correct option is 3 mole followed by 2 mole followed by 1 mole. Guys, the correct option is C. Remember, such type of questions have been asked many a times, and this is also important as per like calculation of want, like calculation of want of factor as well in case of solution, guys. Remember, very, very important. Okay, come on, let us go ahead for the next question then. So guys, here we have the next question before us. Correct increasing order for the wavelength of absorption in the visible region for the following cobalt 3 complexes. Okay, so here we have to compare, guys. Remember, two things we should know. First of all, guys, wavelength lambda is related to, yes, it is related to, yes, CFSE, crystal field stabilization energy delta O inversely. The complex which has more delta O will have least wavelength. So remember, wavelength of absorption is inversely proportional to delta O of ligand attached with central metal ion. Now, according to spectrochemical series, guys, here we have 3 ligands. Yes, we have 3 ligands, ethylene diamine, then ammonia, and then water. Okay, so according to spectrochemical series, guys, it is very, very clear that CFSE, guys, a strong ligand will have more delta O. And if it is having more delta O, that means the wavelength of absorption will be lesser. As if delta O is more, lambda will be lesser. If delta O will be less, that is weak ligand, its lambda will be more. Done. And the order of all the 3 ligand from spectrochemical series is this one. Guys, water is the weakest ligand out of all 3 one. Okay. Therefore, guys, here which will have highest delta O? Yes, which will have highest delta O? Ethylene diamine will have the delta O order will be this way. And wavelength is inversely proportional, guys. Therefore, wavelength will be in this order. Suppose delta O ethylene diamine, delta O ammonia, delta O water. Then lambda water, lambda ammonia, lambda ethylene diamine. Sorry, this has to be the least one here. Done. Because wavelength of absorbed light is inversely proportional to delta O. And from spectrochemical series, guys, this is the strength of the ligand. Remember. So ethylene diamine is the strongest one out of here. Water is the weakest one. Therefore, water will have maximum wavelength. Ethylene diamine will have least wavelength of absorption. Remember. Done. Clear, guys? So it can be easily said that, guys, it can be easily said that the ligand, okay, for these ligand, the order of wavelength of absorption in the visible region will be that of the correct order over here is A. Clear? This will have maximum wavelength followed by this one. All clear? Come on. Let us go ahead for the next question then. So we have the next question before us. Pick out the correct statement with respect to this complex. Okay. So it is whether it is sp3d2 hybridized and octahedral, or it is sp3d2 hybridized but tetrahedral, or d2sp3 hybridized and octahedral, or dsp2 hybridized but square planar. First of all, guys, this statement is having no meaning. Which one? sp3d2 hybridized and tetrahedral. Without knowing, looking into much, we can say that this statement is wrong. Because, guys, if hybridization is sp3d2, either whether the hybridization is d2sp3 or sp3d2, the shape is octahedral. Remember. Done. Now let us select the rest of all, guys, here. Sorry. Now, guys, whether D can be having any possibility to be correct or not, let us see that. Here, guys, the complex is having coordination number 6. There are 6 CN minus ligand. Therefore, coordination number is 6. And, guys, square planar or hybridization D2sp3 will have a coordination number 4. Shape is correct. If dsp2 hybridization will be there, it will be square planar shape, I mean geometry square planar. But in that case, coordination number should be 4, remember. Therefore, guys, it cannot be B, it cannot be D. Now let us look for A and C. No doubt, guys, this has a coordination number 6. It can have either D2sp3 or sp3d2, but that all depend on the type of ligand. I mean, that all will be decided by the ligand over here. C minus being a strong ligand, it has the capacity to pair the electrons. Now let us look at the first thing, guys, here. Manganese is in +3 oxidation state. Done. If manganese is in +3 oxidation state, that means it will have the configuration 3D will have, guys, 3D will have 4 electron, 4s will be empty. Done. 4p will also be empty. Clear? Now, CN being a strong ligand, guys, CN being a strong ligand, and it needs for octahedral, geometry. That is whether sp3d2 or d2sp3, it needs only 2 empty d orbital. I'm repeating, it needs only 2 vacant d orbital. So what is going to happen, guys? CN minus being a strong ligand, it will pair this electron up and we will left with 2 empty d orbital like this. Okay, done. Now the 6 pair of electron from 6 CN minus will easily be filled up over here, and the hybridization will be D2sp3, that is inner orbital complex. Done. D2sp3 hybridized. And guys, if it is D2sp3, the geometry has to be octahedral. The geometry has to be what? Octahedral. So which is the correct option here? Very clearly C. C is correct because it is because of the strong ligand. Guys, Cn minus is strong ligand. It will cause pairing and it will make the inner orbital vacant for hybridization to occur. So inner 3D, I mean 3D orbital are going to participate in hybridization over here. Clear? Come on. Let us go ahead for the next question then. So guys, here we have the next question. Which of the following has the longest CO bond length? Remember, free CO bond length in CO is this much. Now guys, CO, it is also like after. It is no doubt, if you look at spectrochemical series, guys, it is the strongest ligand, isn't it? Because of there is the bond order is 3 and there is a lone pair. This lone pair of electron can be easily donated to the central metal atom. Done. Therefore, it is the strongest ligand. Now, guys, free CO bond length is this bond length. I mean, the bond length, bond order is 3, and the bond length of this bond is given as 1.128 angstrom. Done. The question is which of the following has longest CO bond in all these complexes? Done. So that will be decided by, guys, remember guys, that will be decided by the oxidation state of central metal atom. CMA, central metal atom in the coordination sphere. Done. And remember guys, as negative charge on metal carbonyl complex increases. Remember, as a negative charge on metal carbonyl complex increases. Okay. Back pi bonding increases. Guys, very important. Back pi bonding also increases. Okay, and hence bond length off, because back pi bonding means what? This back pi bonding is increasing, and because this will have more attraction towards this one, the bond length has to increase. Because of this back pi bonding increase, guys, what is going to happen? Bond length of CO bond will also increases, remember. But what happens to the metal carbon bond, guys? The bond length of metal and carbon bond will decrease. Remember, this bond, suppose this is the metal, this bond length will decrease because more negative charge over here, more the tendency of this to give uh, electron to this or get pi bonded with this one. So it is very easy here, the bond order is increasing, so bond length will decrease, so metal carbon bond will decrease, whereas CO order bond order, guys, will decrease, or you can say bond length of CO will increase. Clear? Now let us see all of them, the charges on all of them, guys. So in this case, the charge, guys, carbonyl is a neutral, or in fact it is neutral, guys. Here the charge on iron is 2 minus, here it is 0, here it is plus 1, here it is minus 1. So Fe has highest negative charge. Now as per the rule just now dictated by me over here, guys, as negative charge on metal carbonyl complex increases, back pi bonding will increase. Back pi bonding will increase means here the bond order will increase or bond length will decrease. That will result decrease in bond order over here or bond length will increase. Done. So this will have the longest CO bond length. Done. Come on, have a look at the screen for a moment. Done. Let's go ahead to the next question then. So guys, we have the next question before us is, which of the following pair of d orbital have electron density along the axis? Very simple question, was asked in NEET 2016 phase 2. Come on, this is a question. This can be a question of chemical bonding. This can be a question of D block element. This can be asked in coordination compound. Okay, guys. So have a look at the screen. So guys, let us draw dxy first of all. Suppose this is x and this one is y. Guys, dxy will have its lobe between the axis x and y. So this is dxy. Done. Now dyz will have, let this be y, this be z, will have lobes between yz axis. Done. Then dzx, let this be x, this one be z, will have lobe in between x and z like this. So it is very clear from here that whether it is dxy, dyz or dzx orbital, they have maximum electron density between the axes. Have maximum electron density between the axes. Done? Clear? Come on. Let us go ahead for dz square and dx square y square. Guys, dz square have, suppose this is the z axis. It has electron density over the axis, isn't it? Clear? This has electron density over the axis. Now let us see for dx square y square. Let me draw it a bit straight. Okay, suppose this is x, this is y. It will have electron density over the axis like this. Done. This will have electron density over the axis, respective axis. Clear? Come on. So the question is all about which of the following pair of d orbital which will have electron density along the axis. Can you tell me which amongst them all have maximum, I mean the electron density along the axis? Yes, it is the dz square and dx square y square. Whereas all these three have electron density between the axes. Done. Clear, guys? Come on. Let us go ahead to the next question there. So we have the next question before us is, the correct increasing order of trans effect of the following species is. Remember guys, trans effect. What is trans effect? First of all, what is trans effect? Guys, it is the effect. It is the effect of a coordinated group upon the rate of substitution at the position trans to itself. Trans to itself. It is the effect of a coordinated group upon the rate of substitution at the position trans to itself with the respect to the group itself. Okay, clear? Itself, and in which all geometry, guys? Itself either in a square, itself in a square or octahedral complex. Clear? Now, as a rate of substitution, remember guys, as the rate of substitution of the transligand increases, the intensity of trans effect also increases. So rate of substitution of trans ligand is directly proportional to what? It is directly proportional to intensity of trans effect. Done. And that will depend on what? Of course, guys, that will depend upon the tendency to donate. Done. Or yes, tendency to donate electron. Therefore, guys, this will be maximum for Cn minus, followed by C6H5 minus, followed by Br minus, then NH3. Clear? Come on. Have a look at the answer. Come on, which is going to be correct one here? Cn minus will be biggest, then C6H5, then Br, then NH3. This was asked in NEET 2016, phase 2, remember. Let's go ahead to the next question then. So we have the next question before us. Jahn-Teller effect is not observed in high spin complex of. Yes. Now let us see, guys, which all complexes Jahn-Teller effect does observed. Remember, Jahn-Teller effect, or you can say distortion, that is more correctly can be called as distortion. Jahn-Teller distortion is observed in those octahedral complexes in which d electrons are filled unsymmetrically. Are you getting this? Unsymmetrically. Come on, guys, all those who are watching, if you have not liked the video so far, do like the video. Do share the video to all your friends who are preparing for NEET 2021 KVPY and board examination without delay. And all those who are watching the channel for the first time or have not subscribed the channel, by any reason, do subscribe the channel to press the bell icon. Come on, have a look at the screen, guys. So we were discussing Jahn-Teller effect. So guys, Jahn-Teller effect, more effectively called as distortion. It is observed only in those octahedral complex in which d electrons are filled unsymmetrically. Done. Now let us check out of all these d configuration, where is, like, which one is unsymmetrical or which one are symmetrical. Come on, have a look at the screen. So guys, in D4 system, T2G, EG, 1, 2, 3, 4, isn't it? This is EG, T2G. So this is what? Yes, this is what, guys? Yes, it is unsymmetrical. Therefore, guys, it is unsymmetrical because T2G has 3 electrons and EG has 1 electron. Therefore, Jahn-Teller effect will be observed here because Jahn-Teller distortion is observed in those octahedral complexes where d electrons are filled unsymmetrically. Here, this is an unsymmetrical arrangement of electron. Therefore, Jahn-Teller effect will be observed here. Now, let us look for D8 configuration, guys. Simply, D8 configuration will have how many electron in T2G, guys? 1, 2, 3, 4, 5, 6, and 1 electron each. So this one is completely filled. This is half filled. So it is quite symmetrical, isn't it? It is symmetrical. And therefore, Jahn-Teller effect is not going to be observed here because this is symmetrical one. Now let us check for D4. D4 we have already done. Let us check for D7 now. So D7 will have T2G and EG, guys. This D7 will have, first of all, filled single electron. Done. Now, this is again unsymmetrical, therefore it will be observed. Jahn-Teller effect will be observed. Done. Now, let us look for D9. D9 will have the electronic distribution like this. In T2G, all will be filled completely. So this is symmetrical, but here, guys, one electron here, one electron, this will be paired up. So it is unsymmetrical. Overall, this is also unsymmetrical. So Jahn-Teller effect or distortion will be observed here in D9, D7 and D4 configuration because it is observed in those octahedral complexes where D electrons are filled unsymmetrically. Clear? Therefore, the answer over here is D8 because here the electrons are filled very symmetrically. Therefore, Jahn-Teller effect will not be observed in D8 configuration. Clear? Come on. Let us go ahead for the next question then. So we have the next question before us, guys. Cobalt 3 chloride forms several octahedral complexes with ammonia. Which of the following will not give test for chloride ion with silver nitrate? Come on, guys. In order to give test for test for the formation of chloride precipitate, the chloride ion has to be ionizable. And if chloride ion is available in the solution, it will easily get combined with Ag plus, and we are going to get AgCl white precipitate very easily. Done. So we have to look for them all. We have to look for this. So which of the complex will have this? It is easy, guys, which will have chloride ion outside. Now, just before few questions, we have already discussed this, isn't it? So let us look for the A, guys. This has 3 NH3. This one has 3 NH3, and all these NH3 ligand will be there in the coordination sphere followed by all the chloride ion. So in this complex, guys, chloride ion is intact and it is going to be present inside the coordination sphere. It will not be tested. It will not be tested, or it will not get ionized, and it will not get precipitated with AgNO3. So it is very clear from here, this does not give test, no test or no PPT with AgNO3. Clear? Now let us look for B. Guys, this will have 4 NH3 and 2 Cl in the coordination sphere. 1 Cl will remain outside. This will get precipitated. Now C will have CO 5 NH3 in the coordination sphere with 1 Cl and 2 Cl outside. This will also give test for chloride ion. And this D will have all the 3 Cl outside. So this will also get ionized and will give precipitate with AgNO3. Okay, clear? So it is first one, guys, A. It is A, which will not give test for chloride ions. Come on, let us go ahead to the next question. So we have the next question before us. Which of these statements about this complex is true? It has no unpaired electron and will be in low spin configuration, or it has four unpaired electron will be in low spin configuration, or will have four unpaired electron and will be in high spin configuration, or has no unpaired electron and will be in a high spin configuration. Let us check this. Let us do this. First of all, guys, cobalt is in +3 oxidation state in the complex. X minus 6 and the complex ion has a charge -3. So the charge can be calculated out this way. X is equal to -3 plus 6. So it is clear that cobalt is in +3 oxidation state. All clear? Therefore, guys, cobalt is having, yes, what? 3d6 system. Done. It will have 3d6. When cobalt is not, yes, guys, have a look at the screen. Okay. And remember, guys, here 3d6 will have 1, 2, 3, 4, 5, and this. Done. Now Cn minus is a strong ligand. It is a strong ligand. Done. And as it approaches this, all these five orbital guys are going to split up, isn't it? And what will happen? First of all, the electron will get paired up. Remember. And one thing, guys, the splitting of d orbital into two set of orbital can be represented as, here we'll be having T2G and EG, all clear. And because Cn minus is a strong ligand, it will pair up the electron and all the electron will get paired up in T2G set, leaving no unpaired electron. EG set will be empty. EG set will be empty. Done. There is no unpaired electron. Clear? Here there is no unpaired electron. All clear? So which is the correct option over here, guys? Here we have first option. It has no unpaired electron. And because of no unpaired electron, this will be in a low spin configuration. This will be in a low spin configuration. All done. So the correct option is A. Let us go ahead to the next question. So the next question before us is the hybridization involved in complex will be what? Cn minus being a strong ligand. But the very first step is to find out the oxidation number of this central metal atom. Let this be X. Cn has -1. 4Cn will have -4. Net charge over here is -2 on the complex sign. So X will be +2. So nickel is in +2 oxidation state. Done. Clear, guys? Now nickel is in +2 oxidation state and Cn minus being a strong ligand. Okay, guys. So here we can easily say that Ni2 plus is basically a 3D8 system. It is a 3D8 system like this. Okay, done. Now, Cn minus being a strong ligand, it will pair up this electron. This is 3d, 4s, then 4p. Done. So after getting paired up, it will left with one vacant d orbital. Will it be? Yes. Done. Now guys, the hybridization has to be involved with, actually coordination number is 4. So 1d orbital, 1s and 2p. So the hybridization has to be d, s, p, 2. Clear? So 4 lone pair from 4 ligand will come over here and form this complex. With hybridization dsp2, geometry will be square planar. So the correct answer over here is A. Done. Let us go to the next question then. So we have the next question before us. The sum of coordination number and oxidation number of metal M in this complex where En is ethylene diamine will be. Let us see guys. First of all, remember guys, C2O4, oxalate. Guys, C2O4 is actually a, yes, bidentate ligand. Done. Similarly, ethylene diamine is a bidentate ligand like this. Done. Clear? Come on. So guys, it is very, very clear from here that there is one oxalate ion. So denticity due to oxalate has to be 2. And there are 2 ethylene diamine with each one is having density 2 and there are 2 such ligand, therefore total will be 4. So the coordination number has to be 6. All clear guys? Coordination number has to be 6. Done. Now we have to find out what the sum of coordination number and oxidation number. Okay, come on. Let us see, guys. First of all, calculate the oxidation number. Let the oxidation number of M will be X and guys, there is no charge on ethylene diamine. Oxalate is having a charge of -2 and the complex as a whole has, chloride will have -1. So net charge is 0. Done. Therefore, this oxidation number will be +3. Clear? Done guys. So oxidation number is defined as total number of binding site. Oxidation number is calculated, whereas coordination number is what? It is defined as the total number of binding site. Coordination number is defined as the total number of binding site attached to the metal. Clear guys? So the complex will have a coordination number of 6. We have just now seen it. Clear? Done. Therefore guys, sum of coordination number and oxidation number of metal M in the complex will be what? This will be 6 plus 3, 9. So the correct option over here is what? It is what guys? A. So the correct option is the sum is 9. Come on. Let us go ahead to the next question then. So we have the next question before us. The name of complex ion is, guys, this is a negatively charged anion. This is an anionic complex. So the one which is given to us is an anionic complex. Okay, this is an anionic complex. All clear? So what will be the name of this one? Come on, have a look at the screen. So guys, remember anionic complex, whether it is anionic, cationic or the neutral one, the very first step is to find out the oxidation number of central metal atom. Let the oxidation number of iron be X. Cn minus each ligand has got a minus 1 charge. 6 ligand minus 6 charge equals to minus 3, or X will be equal to plus 3. So iron is in plus 3 oxidation state. Done. Now, the name of the complex will start with the name of the ligand. There are 6 ligand. Therefore, guys, it has to be hexacyano, followed by the name of the metal. But as it is an anionic complex, therefore the suffix 8 will be added. Done. So it will be hexacyanoferrate with oxidation state 3, and as it is an iron, so iron suffix has to be there. So it is hexacyanoferrate 3 iron. Done. Hexacyanoferrate 3 iron. Or this can be, guys, this can be written as hexacyanide as well. Cyano or cyanido, chloro, chlorido, all are good, all are okay. You can use that. 3 iron. Okay, you can name this either way. And we have the second option given over here. Therefore, this will be the correct answer here. Come on, let us go ahead to the next question then. So the next question before us, among the following complex, the one which has zero crystal field stabilization energy will be. Done. I know this question is little bit lengthier, but we can solve this, isn't it? Let us see how. Guys, crystal field stabilization energy for octahedral complex is given by CFSE, that is delta O. This is basically given by the relation, guys, minus 0.4 into T2G electron and plus 0.6 into EG electron. Remember, minus 0.4 T2G electron plus 0.6 EG electron. Done. Let us see how it is to be done. So guys, for manganese, let us see the case A. For manganese, guys, this manganese is in plus 3 oxidation state. All done. It is in plus 3 oxidation state. Therefore, this is 3D4 system. Yes, guys, with T2G 3 electron and Eg1 water being a weak ligand. Okay. So guys, water being a weak ligand, this will be the electronic distribution between T2G and EG orbitals. And therefore, guys, here CFSE will be equal to minus 0.4 into T2G electron, that is 3, plus 0.6 into 1, that is EG electron. Clear? So this is, guys, minus 1.2 plus 0.6, simply minus 0.6. So here the CFSE for this complex has to be minus 0.6. All done. Now, guys, let us look for B. Here iron is in Fe3 plus oxidation state. Simply 3D5 configuration. Now, water being a weak ligand, this will has distribution of electron as T2G3 and Eg2. Done. Simply find out CFSE with the same method, guys. Minus 0.4 into 3 plus 2 into 0.6. Now, this is what, guys? Minus 1.2 plus 1.2, nothing but 0. All clear? Now it's turn to calculate. So, guys, here for CFSE, it is minus 0.6 in case of A. In case of B, it is 0. Okay, the one which shows zero crystal field stabilization is which one? Is B. Here it is 0. But let us calculate for C and D as well. For that, you please have a look at the screen for a moment as I'm going to clear the screen. Done? Yes. So let us look for C as well, guys. Water is, come on guys, for cobalt, water act as a strong ligand. And remember, except fluoride, in case of a cobalt complex, all the ligand, mostly all the ligand act as strong ligand. So here also, like cobalt is in +2 oxidation state with 3D7 configuration. Done. And here guys, here what will be the scenario? T2G will have 5 electron, Eg will have 2 electron, CFSC will be calculated as minus 0.8. Now let us look for D. Cobalt is in +3 oxidation state, and +3 oxidation state will have 3D6 with T2G electron 4 Eg2, and here CFSC will be calculated as minus 0.4. The one which is having 0 is the complex given in B. Done. Let us go ahead for the next question then. Which of the following complexes used as an anti-cancer agent? Guys, this question has been asked many times. Many times, guys. Many times. Remember, this time you need to learn this. Guys, it is cisplatin. It is cisplatin. This one is cisplatin. Remember, this is known as anti-cancer agent. Cisplatin. Okay, anti-cancer agent, and this one is the formula of cisplatin. Here the word cis means what? Cis refers to the cis geometrical configuration, guys, or cis isomer of this compound. Remember. Done. And it is used as an anti-tumor agent as well. Anti-tumor agent. Okay, the Cl and NH3 both are present cis with respect to each other. Cis geometrical isomer. Come on, let us go ahead for the next question then. And by the time, all those who have not liked the video so far, do like the video. Do share the video to all your friends who are preparing for NEET 2021 KVPY and board examination, and all those who are watching the channel for the first time, do subscribe the channel, do press the bell icon. Come on, in order to have further notification. Come on guys, let us go ahead to the next question then. So we have the next question before us. A magnetic moment of 1.73 Bohr magneton will be shown by one among the following. Remember guys, remember, if magnetic moment is 1.73, that means number of unpaired electrons should be 1. Remember one thing, the easiest trick over here. If number of unpaired electron will be 1, magnetic moment will be 1 point something. If number of unpaired electron is 2, magnetic moment has to be 2 point something. Number of unpaired electron is 3, magnetic moment will be 3 point something, and so on. So here we should look for the complex which is having one unpaired electron. Done. Done guys. And in calculating all here, copper is in +2 oxidation state, guys. Okay. And here, what is the scenario? Ni2 plus, guys. Cn being a strong ligand, no unpaired electron. Done. Ti plus 4, no unpaired electron. COCl6, 4 minus, that is +2. And chloride being a weak ligand. Therefore, A is the correct answer. Remember, this complex will have one unpaired electron. Chloride being a weak ligand, guys. CO2 plus will have 3d7 arrangement. And if it is 3d7, guys, 3d7 means what? 1, 2, 3, 4, 5, 6, 7. Here, guys, n is 3. Therefore, the magnetic moment will not be 1.73, rather, it will be 3 point something. Are you getting this? Are you getting this? Therefore, this complex will have 1.73 Bohr magneton as the magnetic moment because it is having one unpaired electron. Clear? Let us go ahead for the next question then. So we have the next question before us. Which one of the following is an outer orbital complex and exhibit paramagnetic behavior? Remember, guys, outer orbital complex will be seen in the case where pairing of electron is not taking place and there must be some unpaired electron for paramagnetic behavior. Okay, so let us see all the complexes one by one. In NiNH3 whole 6, 2 plus. Done. NiNH3 whole 6, 2 plus complex. Ni is in +2 oxidation state with a 3D8 configuration. Remember. And here coordination number is 6. Done. Therefore, guys, this will be an outer orbital complex because guys, for 3D8 configuration, no doubt C like ammonia acting as a strong ligand, pairing should occur. But even if pairing will occur, there would be only one vacant orbital will be obtained. Therefore, guys, this pairing will does not take place. No pairing. Remember, this unpaired electron remains 2 over here. And guys, outer d orbital are involved in hybridization. Therefore, hybridization is sp3d2 and outer orbital complex is possible here. So this, of course, is the correct answer as per the question. But let us look for other cases as well. So in case of zinc NH3 whole 6 2 plus complex, zinc is in +2 complex, guys. Done. Therefore, guys, and all 3D10 configuration. So it has to use outer d orbital. So no doubt it will be outer orbital complex. But there are 10 d electrons. So n equals to 0. That is no unpaired electron. Therefore, this is what? This is diamagnetic complex. Are you getting this? Come on, is it clear? Do let me know. Done. Let us go ahead to see then. For that, I need to clear the screen. So come on, have a look at the screen for a moment. Done? Yes. So guys, let us see the C1. Cr NH3 whole 6 3 plus. Chromium is in +3 oxidation state. Done. Now, chromium is in +3 oxidation state means it is a 3D configuration. As it is a 3D configuration, all the 3 electrons are unpaired and present like this in a 2 d orbitals, 2d orbitals in 3d, 2 TWO2 guys. 2d orbitals are vacant, 4s and 4p. So guys, D2sp3, D2sp3. So this will be an inner orbital complex. No doubt due to 3 unpaired electron, it will be paramagnetic, but the complex is inner orbital complex. Done. Now let us look ahead for the sixth one. We have CONH3 whole 6 3 plus, where cobalt is in +3 configuration. Cobalt is in +3 configuration with a 3d6 configuration, guys. Now here, this will have 3d6 configuration like this. Now, ammonia being a strong ligand here, it will cause pairing up of the electron, and we will be left with, guys, this two, yes, we will be left with two vacant d orbital, and therefore guys, this will also be inner orbital complex and diamagnetic because there is no unpaired electron. But we have to look for outer orbital complex as well as the paramagnetic one, and that is there in case of first one only. Clear? Come on. Let us go ahead for the next question then. So we have the next question before us is, of the following complexes, ions which is diamagnetic in nature. Of the following complexes, ions which is diamagnetic in nature. No problem, guys. Let us look at all the complexes one by one. NiCN4 with a negative charge of 2. Now let the oxidation state of nickel be X. Always remember, straight away go to find out the oxidation state of central metal atom. Cn being a negatively charged ligand with -1 charge, so it will be 4 ligands, so -4, net charge is -2. X has to be +2. The charge on nickel is plus. Done. Therefore, guys, as it is +2, this complex is a 3d8 configuration. Isn't it? This is a 3d8 configuration. Now, if it is 3d8, this can be 1, 1, 1, 1, 1, 5, 6, 7, 8. Done. And C minus being a strong ligand, it will cause pairing up of the electron and will be left with one vacant orbital. Done. Will be left with one vacant orbital. Okay. And coordination number here is 4. So 1 d orbital, 1 s, and 2 p orbital, dsp2. Okay, guys, will undergo hybridization and will form what? Square planar complex. But we have to simply look for the unpaired electron. Guys, there is no unpaired electron here. Therefore, it is diamagnetic. This complex is diamagnetic. Done. Now let us look for B1. B. CuCl4 2 minus. Here copper is in +2 oxidation state. Clear? Done, guys. Copper is in +2 oxidation state. As copper is in +2 oxidation state, it is a D9 system. Done. It is a D9 system. Okay. Chlorine being a weak ligand, and even if there will be like pairing There is no unpaired electron left over there. Or I mean, what is there, guys? What is there? If it is 3d9, chlorine, even if it is strong or weak, guys, d8 d9 system pairing is not possible because d orbital won't be vacant, won't be resulted as a vacant one. So it is clear from here that we have 1 2 3 4 5. Just a sec, let me redraw this. 5 orbital with 1 2 3 4 5 6 7 8 9. Now this electron will remain unpaired. Okay, guys. And therefore, this is paramagnetic. Remember, this is paramagnetic. Done. Now, let us look for complex C here. In case of complex C, guys, this is a cobalt. Yes, COF6 with what? -3 charge. Let us find out the oxidation state of cobalt. X, and on fluorine, guys, -1 charge is there. So it will be X minus 6 equals to what? The net charge on the complex -3. So it is X plus 3. Cobalt is X plus 3 system. If it is X plus 3, it will be a 3d6 configuration like this. 4 unpaired electron because fluoride being a weak ligand, it will use outer d orbital. So hybridization has to be sp3d2, outer orbital complex. But there are 4 unpaired electron. Therefore, the compound has to be paramagnetic. So the correct answer is A only. Correct answer is A only. Hope it is helpful, guys, and you got this understood very, very well. Come on. So thanks a lot for watching, guys. If you have not liked the video so far, do like the video. If you have not subscribed the channel so far, do subscribe the channel. Do press the bell icon and try to get the subscription applying this referral code of mine. Thanks a lot for watching, guys. Bye-bye for now. All the very best to you. Keep rocking.